Hi, hello guys. So let's start with a revision of our entire chapters we have done till now. Okay, those are the 4 chapters we have done till now. So let's start with it. Okay, and okay. So our very first chapter, that is the geography as a discipline. Okay. So here we have to know the fundamentals of physical geography. So this chapter, to sum it up, okay, all in one, it's nothing but to just to make you all understand that our syllabus for the class 11 is naturally focusing towards the natural science. Okay, so geography we will see further that geography has been differentiated into 2 parts: physical and human aspect. Okay, so here we are doing the physical geography, and physical geography when we do, we mostly rely on the science part. Okay, it naturally comes on the natural science. Okay, and the human geography, it comes under the social science. So for class 11 we will be doing the physical science. Okay, physical geography, that is the natural science. Okay, so always keep in mind, and this chapter as a whole, it just sums it up to that. Okay, but as it is our first chapter and there are few things you all need to understand and learn, so I'll try to make it much more simpler. Okay, so that you, when you open your book, you don't have to go through all the stanzas and all. I'll try my best to make it much more simpler. Okay, so today is just going to be a revision, so I'm just going to do the main points. So we'll start with the fundamentals of physical geography, and let's learn about the physical environment. So what is a physical environment? Everything, okay, everything that we see around us is a physical environment, but those are the non-living. Okay, now I'm not talking about the animals around, I'm not talking about the trees around or the humans around, I'm not talking about even the culture or anything. I'm just talking about the physical aspect of an environment: the land, the water, the air. Okay, so there may be variation in the lands. The land can be a plain land, the land can be a hill. There may be variation on the water resource. Maybe it's a lake, maybe it's a pond, it's a sea, or a river, or a huge ocean. Okay, so and maybe it can be a air, maybe it can be a wind. Okay, maybe it can be a breeze. So all this aspect is your physical environment. So that is all we are focusing. We will be focusing on in this year. Okay. So, and then we have the second point as a physical feature plus human culture. Okay, physical feature plus human. Now, when we look back, okay, from ages and ages old, okay, our primitive forefathers, they were directly in relation to the environment. They used to till the land, they used to get the agricultural goods, they used to go for hunting, okay, they used to live in caves, so they were directly related to the nature. Okay, and this has enhanced with their culture. Like for example, the people of the Middle Eastern countries, they are mostly non-vegetarians. Why? Because those are the desert land. Okay, those are the desert land. The soil is very sandy. There is no vegetation there. Okay, you cannot go around farming there. Okay, now there are few exceptions like dates and palms, but you cannot eat and survive on them, right? So people, they mostly rely on the animal husbandry, animal goods. Okay, so they eat meat, they use leathers and everything. Okay, in the Middle Eastern area, because that is a desert. Now, compare it to the Indian part. In India, most of the people are vegetarians. Why? Because India has always been productive with agricultural goods. Okay, our soil is very fertile. Okay, so this is one of the reasons why the culture has been changed. There, the culture is about having non-vegetarian foods. Here, the culture is about having the vegetarian food. So this is your third example. This is your third point, that physical environment interacting with a human. Okay, interacting with a human gives or results into a culture. Okay, and that culture has been always been followed. So always remember these 3 points. Okay, this three tier: physical feature plus human being is equals to their culture. Okay, so all our culture is guided by our physical environment we live in. Okay, then apart from that, we need to know about the history of the geography as a subject. Now, there was a time when none of the subjects were made, but there were some very intelligent scholars and scientists, okay, back then, who used to wonder, okay, who used to wonder how something was built. They used to look at the star and they used to wonder, what is it? How is it such? Okay, how is it so bright, or how is it such? And then when it was formed. So what, how, and when? These are said to be a variation study. Okay, and these are the very important questions that led to the formation of geography, because this created curiosity, and curiosity is a thirst that need to be fetched. Okay, so they did a lot of study for that to fetch their thirst. Okay, so this variation study gave rise to slowly and gradually to the subject as a whole. And then you see that the physical phenomena is dynamic and not static. Now, what does it imply? Just look at the primitive age and the today's modern age. How different our people are, how different our people behave to the environment. Like, for example, when our primitive forefathers used to go and they used to walk around and there used to be a huge mountain, they couldn't pass through it, they had to either climb through it or go through other ways. But now, the industrialized people, they make a tunnel through it. So, so this is what your next point also suggests is the humanized nature and the naturalized human being. Humanized nature is naturalized human being is something that our primitive forefathers were. They were very much keen to the goings of the nature. They were much more about how the nature guided them, is what I mean. So whatever the activity was directly related to what the nature is giving them. If the nature is giving them, they will do. If the nature stops, they don't have any other option. So that is naturalized human being. And today we are the humanized nature. We are in the scenario of the humanized nature. What we do, we get something more from the nature that the nature is not willing to give. If there is a mountain before us, like I said, we'll make a tunnel through it. Okay, so we are humanizing the nature. We are making changes in the nature. So this is your the other point or the important point, very important point. So these are something that you will need to do in class 12 as well. So if you understand now, it will help you in the later years, and it's not very hard. Okay, it's so easy, right? So what is it? Our primitive father were naturalized human being. Why? They were directly related to the nature. They used to do whatever the nature gave them, whatever the nature provided them, that was enough for them and that was sufficient for them. And even if it wasn't sufficient, they had no other option. But for now, we are the humanized nature. We humanize nature. We use nature on our own will. We'll make a tunnel through anything. We will try to we'll try to purify the salt water of the sea and make it drinkable. Okay, so that thing is going on. So we will drill the oil. We'll go for gold mine. We'll go to coal mine. Okay, so these are the some of the things that we are humanizing on the nature. And then the other aspect is about your time. So so when we study geography on a various discipline, so we see that the geography as an integrating discipline has been has been divided into two parts, the spatial and the temporal. Now, what does the spatial mean? A spatial means a space, and temporal means time. So we study the interrelation in geography. Like, for example, if you are traveling from anywhere, from Siliguri to Darjeeling, now it might take 2 hours for now, but previously in the bullock carts it used to take around 6 hours, 7 hours, maybe 12 hours. So this is the difference, okay, and this is the dynamic nature of the physical geography, okay. It changes, and we are studying the distance according to the time, okay. When you are asked how much, what time did it take to reach from one place to the other, we always reply it on time. It took me 3 hours to reach there. It took me 4 hours to reach there. So this interrelation is what we study geography as an integrating discipline: the spatial synthesis and the temporal synthesis. Okay, and this also shows that with science, geography too focuses on the space and time, because if you all have done it, okay, if you all have done it in your junior classes, if you all have gone for, if you all have, would have gone for chemistry labs or bio labs, and when they used to do some tests, okay, when they used to run some tests, they did the test on a physical basis on a certain place, okay, and then they waited for a time. They did the test on a space, okay. Space means a place, a land, okay, or space, and then they waited for a time. Let's wait for 5 minutes, and then the reaction will start. So just like a natural science, geography too depends on space and time. Okay, so this interrelation is what we study. as an integrating discipline. And other thing is, geography has been differentiated or divided on the basis of the regional approach. Okay. Now, regional approach, choosing a region and approach means to start. Okay, you are approaching. So, what are on those approaches? What are you starting? You do the regional studies. Now, in regional studies, you will suppose you are a researcher. Suppose you are writing a thesis. You want to write a thesis on a certain point on the physical geography. As we are doing the physical geography here, let's focus. We are doing something on the rocks. So you want to study the rocks of Siliguri. Okay. Now it's up to you whether you will choose your study to be confined to Siliguri, or maybe you'll join Jalpaiguri and Siliguri, or maybe you'll join Jalpaiguri, Siliguri, and Darjeeling. So it's up to you. So how much land you are choosing, that matters. So regional studies is your first part. And here, what are the 3 points needed? The micro, meso, and the macro. Whether you are choosing a small land, a very small land, a small land, and a larger land. Okay, and then you have the regional planning. How you are going to do your study? You have to have it in the back of your mind, right? How are you going to do your study? What study are you going to do? You need some planning, you need some strategy. Okay, I'm going to cover this much area today and the remaining area the next time. So that planning is needed. So this is called a regional planning. And then you have regional development, very important. When you go to survey on a certain point, why do you survey is because you want to develop that place in anyhow, whatever you feel like. You will always be productive if you are studying on the rock. You will always be productive if the rock is of any value. If you see any kind of an petroleum or oil or coal inside that interior of the earth, okay, you will always be looking for that. You will always be searching for the minerals, because if you really search for the minerals, it will be beneficial to you as well as for the land, as for the people. So development is important. All of the planning and the studies is because you want to develop in somehow or the other mean. So regional development is the third point, and then we have the regional analysis. So analysis on what way you are gonna present your study, on what way are you gonna present it, whether it's gonna be only theoretical, okay? Because theory is needed, right? We have to write at least the introduction and everything. Okay? So whether you're gonna write whether you're gonna make it theoretical, and then you're gonna add some cartography and statistics, okay? Because all the mathematical formulas and all the numbers and all, if you wanna give, okay, if you are doing some radiometric study, you have to give some datas on it. If you're gonna add that, if you're gonna make some cartographies are all the diagrams and all. If you're gonna make some pie charts, so dot maps, diagram that you will see in your book. Okay, your book is always filled with a diagram. Whenever there is like any kind of a study, whether it's showing a rock, okay, the diagram always has some division, like this area, igneous rock, sedimentary rock, metamorphic rock, right? So if you want to show all those, so this is your regional analysis, how you are gonna present your study. Okay, and then we have physical geography and its importance. So physical geography and its importance. So when you are going to study this, always remember it on the 3 points. What are the physical geography? Lithosphere, that is the land; hydrosphere, that is the water; and atmosphere, that is the envelope of gases surrounding you. Right? We did it in our junior classes. So whenever you are, it's told you to write the importance. Just divide it into 3 parts and write the importance. Land is where we all exist, right? We make homes here. We tilt our land. In lithosphere, we do everything. That is all physical feature. Hydrosphere, we need water. We need hydroelectricity. Everything for drinking, washing, everything. So this is one important. Atmosphere, you need. Without air, you cannot survive. Right? Oxygen is in air, so you cannot survive without that. So all these are the importance that I do not have to so much go on to it. Okay, which you all will do much more better. So yeah, then let's talk about the main thing in this first chapter is the differentiation between the geography as a social science and geography as a natural science. Now, in class 11, we are doing geography as a natural science. In class 12, we'll do geography as a social science. What is the difference? Social science combines all the subjects like economics, social science, and human geography, and all of your social geography, and then your rural population, urban population, how your infrastructure is going, tourism, what industry you're working on. That is social geography that we don't have to consider for now. And in natural geography as a natural science. So what are the natural science? Geography and natural science combined, we get the subjects like climatology, hydrology, soil geography, geomorphology, zoology, ecology, environmental geography, plant geography. So these are some of the subjects that we get when geography acts as a natural science. Okay, so here a lot of the scientific reasoning is needed, a lot of hypotheses is needed, a lot of theories are needed. Okay, so this is how we will deal with it. So just see, you have this diagram. The right side shows all the human geography aspect, okay, human aspect of geography, and the left side shows the physical aspect of geography. Just take a look here: hydrology, climatology, biogeography, okay, geomorphology, meteorology, pedology. Okay, so these are the physical geography. Now let's come to our second chapter, that is the origin and evolution of the Earth. So we are starting very slowly. We are starting from the base. Okay, and these are few subjects, few chapters that we have already done before in your junior classes. Okay, so before starting with the entire geography or the rocks and the minerals or anything, let's first study the origin of the Earth. Okay, and the origin, and not just origin but the evolution of the Earth as well. And why evolution? And that is because we'll understand it later. So let's start with the origin of the Earth. There was a German philosopher named Immanuel Kant who gave the very first hypothesis on how the Earth was created. He said that there was a cloud with a youthful sun and that was slowly rotating. Okay, rotating just like Earth rotates on its axis, it was slowly rotating. Then in 1796, there was a person called Laplace, and then he modified it and he said that the sun was in a youthful stage, like it was just forming. So this is the nebular hypothesis. And then to add on this, there was a person called Otto Smith and Carl Whisker. Okay, so this were the two person, and they were the Russian scientists, and this is of 1950, quite very long time back, long time after a long time. Okay, and they said that yes, the nebula hypothesis is correct. And the nebula hypothesis is correct, but just that the nebula gas comprised of hydrogen, helium, and some dust particles. Okay, and friction and collision of particles created planets. They all believed on the nebular hypothesis. Now, there is a very strange fact about why the Otto Smith and Carl Whisker in 1950 they agreed to such an age-old hypothesis because they were working on Germany for this. Okay, so they were working on Germany, and when you work on a certain country, of course there will be some kind of a pressurization to prove their own scholars right. Okay, so that's some few things. So they didn't have any options, so they went with this theory. Okay, yeah, that's correct. Now this is origin of the Earth. And this is the nebula hypothesis. Just see here in the diagram. At the very beginning, at the top left hand corner, you see there is some kind of a youthful sun. There's some kind of a bright feature at the between, and then there are lots of gases around. Okay, and later on, okay, with what Otto Smith and Carl Whisker said, friction and collision of particles started to separate from each other. The lighter elements, the hydrogen and the helium, they started to move inside, okay, inside the core, and the heavier elements they started to move outside. So it's all made in ascending point. It's kind of believes that the lighter elements are in the middle, and then the heavy elements form the other planets. Okay, the much more heavier, the much more last. Okay, so it was believed that, and then it slowly started to separate, and then we have our solar system how it is formed now. You see in this diagram. So this is nebula hypothesis. So before going to the origin of the universe, let's talk about few more theories that was given back then. In 1900, there were two persons called Chamberlain and Moulton who claimed that a wandering star approached from somewhere, okay, and they didn't mention from where, and they just stuck to this youthful sun back then, and it formed a cigar kind of a shape, and later on that youthful sun became a sun, and the other star that came wandering, it broke down into smaller planets. Okay, so this was one of the theory given, and then there was another theory called binary theory. Okay, and according to that, some kind of an interstellar or cosmic planet Okay, some kind of, let's to make it simple, let's say there was a satellite for the sun. Okay, just like Earth has a satellite that is moon, there was a satellite for the sun, and then they were always like that. And in due time, it broke down into lots of planets. Okay, so this was something called a binary theory. Binary means two, so they believed there were always two planets. Okay, one main, okay, the sun, and then other there was a satellite which broke into lots of planets. So this was some of the theories given, and this is the origin of the Earth theory. Okay, now this was so much debatable. This was very much debatable. Nebula hypothesis was much more considered good. Okay, it was much more near to truth. But then this wasn't enough. And our scientists and researchers, they were much more hungry for a lot more things. Okay, so what they went with, they said that forget origin of the Earth. Let's study origin of the universe as a whole. Okay, now universe is the biggest thing, and inside universe there are lots of galaxies, and inside galaxies there are lots of solar systems, and inside one of those solar systems is our Earth. So they wanted to study the whole of the universe, and then they came up with the Big Bang theory, okay, given by Edwin Hubble in 1920. There is a Hubble telescope named after him. Okay. In 1920, a person called Edwin Hubble, he gave the Big Bang theory, also known as the expanding universe theory. So why is it called an expanding universe theory? Take this example. See this balloon. The dots, they are the galaxies, and the balloon as a whole is the universe. It was claimed back then, like that. So when it expands, the galaxies, they move apart from each other. Okay, so this is the reason for this study. Okay, so it believes that the universe is going on expanding, and the more it is expanding, the galaxies are getting farther and further apart from each other, much more far from each other, just like here in the diagram. But then, when this experiment is done, it is seen that even the galaxies, they expand, right? Because it's a balloon and it cannot be 100% true. And till now the universe is expanding, but and our galaxies are getting far and far from each other, but galaxies do not expand. Okay, so that hasn't been clear. But according to this diagram, according to this experiment, even the galaxies are expanding, right, in the balloon. Okay, so that's why the reason Big Bang theory, okay, theory is correct, okay, and nebula and sorry, expanding expanding galaxy hypothesis, okay, expanding hypothesis, expanding universe hypothesis, okay, because hypothesis, when it is proved, it becomes a theory, and this experiment couldn't prove all in all, okay, because galaxies do not expand, and so it remained a hypothesis, okay, it couldn't become a theory. But still, we get a picture from here. It's not 100% correct, but we get a picture from here that the universe is expanding, and the more it expands, the galaxies get further and further apart from each other. Okay. So, where does Big Bang theory start from? Big Bang theory, okay, as I said, it starts from a single atom. Okay, a single atom with a very small volume but infinite temperature and infinite density. Okay, there was a single atom, very single atom, which had a very small volume. Okay, very small volume, and but it had an infinite temperature and infinite density. One day it suddenly bursted down. Okay, there was an explosion, and all of the energy got scattered for a very large distance. Okay, and those matter, with the time it got converted to, and those energy with time it got converted to matter. Okay, and now it's proved that the explosion took place around 13.7 billion years ago, and so this was one of the thing. And let's talk a few more about the expansion, about the Big Bang theory. Okay, so you all know now, right? A single atom with infinite temperature and infinite density, it exploded, gave out a lot of energy for a lot of distance, so long that the universe is still expanding today. Okay, so there's a lot of energy, and that energy, okay, now giving out universe energy converted to matter and antimatter. Okay, so when that energy was given out, now those energy with time, okay, it converted to matter and antimatter. Now antimatter is also a thing. Okay, now they both collide with each other and they both destroyed each other. Now whichever of the matters survived, they form the protons and the neutrons. Now, protons are positively charged and neutrons are negatively charged. So around 1 billion, then after billions of years, okay, of course it takes time. The temperature dropped to 1 billion degrees Celsius, okay, and that was cool enough to mix and alternate or mix and attract and form hydrogen and helium nuclei. Okay, so the nuclei is being formed, not an atom, but inside the core of the atom, the nuclei. Okay, so the hydrogen and helium nuclei is formed by this. Now, after 3 lakh years, okay, now the hydrogen and the helium, it cooled down. Okay, the temperature cooled down around, and the hydrogen and the helium, they both attracted much more of the atoms. Okay, the much more of the material, and it formed an atom. So from here, it started to form matter, and from matter, that slowly and gradually started to form planets. So this is the Big Bang theory. Okay. Now, where was the single atom formed? Okay, so if you get the question, how is a single atom formed? If they say that the single atom is the core of the black hole. Now, black hole is just opposite to the Big Bang theory. Now, Big Bang, okay, the single atom gave out this entire universe. Black hole is something that will destroy the entire universe. Okay, that's a place where there is an infinite gravity, and